Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. Guys, today we're going to wrap up logs, and we're going to wrap it up by talking about how to solve properly exponential and logarithmic equations. This is very, very important. This is very, very important. So let's pay attention to some skills here and some properties. An exponential equation is any equation that contains the form b to the cx. You have a base b and you have an exponent. Now there's an x there. The c is a constant. It could be 1, it could be negative, it could be a decimal, but there's an x in the exponent. That's what makes it exponential. Such as a equals b to the cx, where the exponent includes a variable. That's the big key here. This is exponential because the exponent includes a variable x. You can use logs to solve exponential equations. You could use exponents to solve logarithmic equations. Let's think about that statement. Logs are the inverse of exponents. Exponents are the inverse of logs. So I can use logs to cancel out exponents, and I could use exponents to cancel out logs because they are both inverses. So let's see what we got here. Let's first talk about solving exponential equations when you have a common base. When you have a common base, guys, we've done this already before. There's nothing new here. You got to think outside the box. You got to say to yourself, okay, can the number 16 and the number 8, can they be broken down to some common base? And can they, my brothers? What is 16, guys? What is 16? 2 to the 4th power. Oh, let me get out of yellow. So this is 2 to the 4th power, but raised to the 3x, right? Because there was already an exponent. Equals 2 to the 3rd power. We learned this already, guys. What happens when we have a common base? They cancel out and you solve the exponents. So now you have 12x equals 3. So x equals 1/4. And that's how you do that. Does everyone see that? That's when you have common bases. Common bases. How do you know if you have common bases, Moto? You just know or you don't know, guys. But if you don't know, trust me, I'm going to get to the next step. You could do it by using log. But it's so much easier if you could recognize common bases. I mean, infinitely easier, infinitely quicker. Much more efficient. For example, 27 to the 3x equals 81. Can I break down 27 and 81 into some sort of common base? What is 27? 3. Okay. We're going to play this game today. All right. Let's see how many times they'll do it today, guys. All right. So this is 3 to the 3rd times 3x. Thank you, my brothers. And then 81 is 3 to the 4th. Plagada, plagada. 9x equals 4. X equals 4/9. Does everyone see that? Questions, comments, concerns, guys? Okay. So that's nice and easy. We've done that before. When the bases are not the same, solve the equation by simply taking the logarithm of each side of the equation. If m and n are positive and m equals n, then the log of m equals the log of n. What's happening is this, guys. Just like when we had the same base here of 3 we canceled, if I've got a log of 9 equals the log of x, well, guess what, brothers? Cancel out those logs, man. And 9 will equal x. Now, for those of you that are saying, okay, I believe you, Moro, but I don't know why. Why did you do that? Remember what I said at the beginning of this lesson. You can cancel out exponents with logs, and you can cancel logs with exponents, right? Let me prove what I'm saying. What's the base of a log proper, just a log like that? Well, guys, if I raise each of these to a base of 10, what's 10 raised to the log base 10? Cancels, so I have 9. What's 10 raised to the log base 10? Cancels. And that's why when you have logs of the same base on both sides of the equation, just like having same common bases of exponents, cancel those suckers. So with that in mind, let's look at the magic here, because there's magic. Okay, 15 and 285, I'm pretty good at this. Unfortunately, guys, there's no common base between 15 and 285. We're a little scarred. But I can drop an exponent by raising everything to the log, by logging everything. So you know what I'm going to do here, guys? I'm going to literally log both sides. Now, when I'm logging both sides and I'm working with equations, what I'm going to do is I'm going to use my properties of log and I'm going to expand the log that I just formed. I'm going to expand, and you'll see why we do that. When I expand this log, bless you, where does the exponent go? Thank you, my brothers. So this is 3x times the log of 15. I just want to do that side right there. I did it in red. Does everyone see this side, what I did, how I did it, why I did it? Okay, cool. Now on the other side, guys, in green, it's just a log of 285. Come again? Okay, yes, but you don't want that much of an expansion because in this case, remember, the only reason why I used the property was to get this out of the exponent. Because while it's in the exponent, I can't do anything with it. Okay, but now what do we have? I have this multiplication. I want to solve for x, right? So let's go ahead and divide by log of 15 to both sides. Now, guys, this is going to be very simple or very difficult for you. In your calculator, you simply put log of 285, close the parentheses. You're going to go log, parentheses will open, of 285, close the parentheses, divided by log of 15, close the parentheses. When you get that, guys, you're going to get a really long number. Do not round it. Do not write it down. Do not truncate it. Do not do anything. Leave it like that on your calculator. Use the power of your calculator. Whatever that value is, I'm going to write the whole one. But I'm not going to do this because it's too long to write it down. How do I solve for x? So, guys, just to that answer right there that's on your screen, just go divided by 3. What does x equal? And I'll probably make you round to the nearest, probably thousands. So 0.696. Do you see how I use log to drop down the exponent? Does it make sense? Okay, number 2. Number 2, my brothers. 5 and 130. Do you think I could get the same base from a 5 and a 130? No, unfortunately not. So I'm going to log both sides. When I log both sides, I'm going to drop that exponent down to the front. So it's 2x log of 5 equals log of 130. Divide by log of 5. And then divide that answer by 2. And that's what x will equal. So it's going to be log of 130, close the parentheses, divided by log of 5, close the parentheses, equals, divided by 2. Everyone should get 1.512. And that's rounded to the nearest thousands. Questions, comments, concerns, problems, issues, dilemmas? Talk to me, my brothers. I want to make sure you guys really, really get this. Okay. Yes, sir? Okay. Now, guys, a logarithm equation is an equation that includes one or more logarithms involving a variable. Let's solve each logarithm equation. Now, let's think. Sometimes we use logs to drop down an exponent, right? What do you think we would use to get rid of a log? Powers, yeah, powers. So we can look at this one of two ways, guys. Here's the easy way. Ready? What's the base of a log? So there's an invisible 10 here, right? Isn't this in log form? Can I turn this into 10 to the second power equals the answer of 4x minus 3? Because remember, base to the y exponent equals the answer. Boom, I'm done. Look how lovely that was, right? So now what do I get? I got 100 equals 4x minus 3. Add the 3. So x equals 103 divided by 4. Please remember that whenever you have an answer for a log, remember what we had talked about. The inside part here with the x has to be greater than 0. It cannot be a negative. Sir, my brother. Thank you, my brother. Log base b of the answer equals the exponent. 10 to the power of 2 equals the answer 4x minus 3. So x equals 103 divided by 4. Thank you so much for your honesty. Does that make sense, guys? Promise. Okay. Next, what's the base of log? So this is 10 to the negative 1 equals 3 minus 2x. What's 10 to the negative 1? 1/10 or 0.1 equals 3 minus 2x. Subtract 3 to both sides. So this is negative 2.9 equals negative 2x divided by negative 2. X is going to equal 1.45, right? Bam, done. Does this make sense, guys? Do you see what I'm doing? Do you see the logic? That's why the first day of log was so important. And I told you guys, you got to know how to go from log to exponential. If you know those and the properties, equations are easy. If you don't know those are the properties, equations are a miserable, miserable mess. Sir, my brother. 1 minus 3, 0.1 minus 3 is 2.9, negative. Because 10 to the negative 1 power, sir, is 0.1, 1/10. Thank you, sir. Okay, next. Log log of x minus 3 plus log of x equals 1. I've got an expanded thing here. I need a single log. So what is this single log reduced to? Log x times x minus 3 equals 1. Thank you. So this is an invisible base of 10. So 10 to the first power equals x squared minus 3x. So 0 equals x squared minus 3x minus 10. So when I factor, bless you, this is x minus 5, x plus 2 equals 0. So x equals 5 and negative 2 using zero product property. X cannot be negative 2 because negative 2 minus 3 is negative 5. So that does not work. And my answer for this one is x equals 5. That's real math, guys. That's fun. But you had to do a lot of things here. You had to know how to factor. You had to know how to distribute. You had to know how to go from log to exponential. You had to know the zero product property. And then you have to evaluate and make sure that the variable part of the log is never, ever, 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 ever negative. Questions, comments, concerns? Okay, then I'm moving on. All right, so now we got log 6 minus log 3x equals negative 2. How can I condense that to a single log? So this is 10 to the negative 2 equals basically 2 over x, right? Right? So what's 10 to the negative 2? 0.01 or 1 over 100, either way. What do you guys rather? 1 over 100 or 0.01? Okay, so this is 0.01 equals 2x. Multiply x to both sides. So x times 0.01 equals 2 divided by 0.01 divided by 0.01. So x equals 200. Bam. Talk to me, baby. Talk to me. And of course, you could check these, especially if it's a log. If you got log of 6, okay, let's put that in, and then go minus log of 600. Log of 600 is better be negative 2. It is. Does that make sense, guys? Okay. Natural logs, guys. The good news: natural logs and common logs. Thank you. Have exactly the same identical 100% properties. I promise you. I swear. What that means that you expand them the same way? Yes. That means you condense them the same way? Yes. Yes, 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 and yes. What's the only difference between a common log and a natural log, guys? What's the base of a common log? 10. And the base of a natural log? That's the only difference, guys. The function y equals e to the x has an inverse. It's the natural log. Remember, exponentials inverses are logs. Logs inverses are exponentials. So the log base e of x, we don't write log base e. We always write ln. That means it's a log base e. That's it, literally. Remember what I said before. If you have a log of a base times the same base, they cancel. So ln of e cancels. Why, modal? Because it's log base e of e, and that cancels. And that means that e to the ln power, that cancels as well. So just like in regular common logs, exponents cancel out logs, and logs cancel out exponents. It's identical. Look, natural and common logs are simplified and solved the same way. So literally, I could end the lesson right now, and all of you have the same skills. But I would never do that to you. But let me prove to you that there's nothing hard here. Guys, what does a 2 mean when you're multiplying in front of the log? So this is ln of 15 to the second power divided by, right? Because minus goes to division, right? Minus divided by 75. So 115 squared is 225. 225 divided by 75, that's like 3 or something. 3 divided by 75 is, 3 on the money. So this equals the ln of 3, my brothers. Like, all joking aside, no sarcasm, do you see how that's exactly the same? The only difference is that it says ln instead of log. But remember, ln is a log, but just at the base of e. People see the ln and for some reason they really stress out and they flip out and they just, no, it's too much. No, it's not. No, it's not. Don't do it to yourselves. How about this one, guys? What does plus mean? How do I condense up? Thank you. So this is the ln of 7 times 5 squared. So that's the ln of 7 times 25. So that's the ln of 175. Make sense? My man. Good job. How about the rest of you guys? How are we doing? Okay, next. 3 ln of x minus 2 ln of 2x. Well, you tell me, guys, what do I do here? ln x to the third 2x squared. So this equals ln of x cubed over 4x squared, which equals ln of x over 4. Do you see how I went all the way there? If you did not see it, guys, you need to ask me. I've only got 8.5 minutes left, and I got one more slide, but I want to make sure I do my job. This makes sense, my brothers. Okay? How do we do this one, guys? Tell me, talk to me. Do it. ln, okay, because we're doing a single log, x cubed times, no, we're doing a single log, y squared times 5. So this is the ln of 5x cubed y squared. Boom, bam, bing, done. Remember, when we're going from expanded to single log, think about the name. Single log. You only have one log. When I'm expanding, that's when I have multiple logs, my brothers. May I continue? Last page. Yes, sir, my brother. Thank you for your honesty. It is multiplied to the y. Right here, they're all being multiplied together. I can do that in any order I want because of commutative property of multiplication. The same 5 times x cubed times y squared. I could have written it as 5 times y squared times x cubed. No, distributive would have been, remember this. First of all, there's a plus, and secondly, there's a parenthesis, and then I distribute. So no, that's just pure multiplication. Remember, guys, if there's nothing in between numbers or variables, they're being multiplied. Okay. Okay, so now we're going to solve. Guys, don't stress. Don't stress. What's the base of ln? So e to the 4th power, right? Base to the exponent, right? Right? Hello? Equals x minus 3 squared. Are you with me here so far? Okay. Okay. Let's see what we got. How do I get rid of that power of 2? Hell yeah. What's the square root of e to the 4th? E squared. Beautiful, guys. Go ahead and add 3. So x equals, what is that modal? X squared, x equals e squared plus 3. So go ahead carefully in your calculators, carefully. It's going to be second function, ln, which gives you the e, should open up a parentheses for you. You're going to put 2 for the exponent squared. So there's going to be e raised to the second. Close the exponent. Get out of the exponent. And now go plus 3. That's the way it should look in your calculator. And it should equal 10 point, let's go to the thousands. Tens, hundreds, thousands. Does that make sense, guys? You got it? Does that make sense, brothers? Okay. All right, let's see if we could do these all in 5 minutes. I think we can. All right. Good. You got it. He started already. He's not wasting time. E to the 4th equals 3x plus 5 squared. Square root to get rid of that power of 2. E squared equals 3x plus 5. Now, for those of you, I'm surprised no one has called me on this. Why are we not doing plus or minus? Because, yeah, that x can't be negative. Very good. So now I'm going to subtract 5. So e squared minus 5 equals 3x divided by 3. X will equal. Do the math properly, guys. Second function, ln, that's my e, raised to the second power. Close that parentheses. Get out of the exponent land. Then you go minus 5. Hit equals divided by 3. And you should get 0.796. If you do not, please let me know so I can help you. Sir, my brother. Huh? Okay, it's E. It should look exactly like this, my man. E squared. So you got to go second function, E. Now go squared, close the parentheses, get out of the exponents, go minus 5, hit enter. Then divide it by 3. Thank you, sir. Now, if you want to do it all in one step, guys, try this. Open parentheses. E squared minus 5. Close parentheses divided by 3. It will give you the same exact answer. But if you do this in your calculator, E squared minus 5 divided by 3, what it will do is this. It will take the E squared and then it will subtract the 5/3. That's not what's happening. The E squared minus 5 here, that value is being all divided by 3. Thank you, guys. Thank you. Okay, got a couple minutes left. This guy right here, e to the second power equals x. That's easy. Second function ln squared x equals 7.389. Let's look at e. Okay, first thing I'm going to do, I'm going to subtract 2 to both sides. I got 4e to the 2x equals 12. No, equals 14. Divide by 4. E to the 2x equals, we could do 14 divided by 4 to make life easy, and that's 3.5. How do I drop down that exponent, though? Remember, I can get rid of logs by raising to powers. How do I get rid of powers? By logging both sides. But in this case, we can't deal with log. We got to deal with ln. So now this is going to be 2x times ln of e equals ln of 3.5. What does ln of e? What is ln of e? Cancels. So divide by 2, x equals ln of 3.5 divided by 2. What does x equal, my brothers? So I got second function, ln. No, not second function, sorry. Just ln. 3.5, close the parentheses, divided by 2. You should get 0.626. And the bell's going to ring in about 30 seconds. You have a couple more. If I were you, do them. And of course, homework is valid. Next week, we're testing. Thank you very much. Hope you learned a lot. Perfect timing. Have a great day, and God bless you all. Bye-bye.